I'm Nikki, an engineer with Dunningthorne Consultants based in Wellington. I want to try and explain engineering and the earthquakes in a simple, non-jargon filled way. What do engineers do? Basically, we design the bones of a building, the columns and beams, the walls and the floors, all of the things that the building needs to stand up. We also design for the sideways loads, wind and earthquakes. After this is all done and built, the architects get to come along and pretty up the building. They get to add the lightweight internal walls, the carpets, the paints, the ceilings, all the things to make the building usable. Services engineers get involved and design things like the plumbing, the heating and ventilation, and the sprinklers, all the things the building needs to be habitable. What are we coming to check? After the earthquake, we're coming to look at the skeleton of the building to make sure it hasn't been damaged. This is why sometimes we need to look behind jib walls and pop ceiling tiles. In an earthquake, each floor of the building can move differently to the ones above and below it. This means that things that run from floor to floor, things like stairs, ramps, or some walls, can get pulled in different directions. Some buildings may be shut even if the earthquake hasn't damaged the shell. This is because the elements that are added later, the water pipes, the ceilings, the cupboards, also have to go along for the ride with the rest of the building, and they can get damaged. Why has there been damaged? 1 in 500 year versus 1 in 25 year earthquakes. We typically design a building to remain standing in a 1 in 500 year earthquake and to remain undamaged in a 1 in 25 year earthquake. So after a 1 in 25 year earthquake, you should be able to come in to the building the next day and resume life as normal. But if the earthquake is larger than this, then the building owner may need some time to repair. If you wanted a new building, we'd design it to last 50 years or have a design life of 50 years. What happened in Wellington? Every building reacts differently or shakes differently during an earthquake. This depends on how tall it is, how stiff it is, what it's made of, and the soil that it's on. Taller buildings move back and forth slower than short, stiff ones, and buildings that are on rock tend to perform better than ones on metres and metres of soil. Think about a bowl of jelly. If you shake it, it will keep on wobbling after you finish shaking the bowl. It appears that the short, sharp earthquake waves didn't make it all the way to Wellington. This helps explain why people's houses and most of the little buildings along Cuba Street tended to perform well and generally aren't damaged, whereas the longer waves travelled up to Wellington and shook the taller buildings more. Let's look at some graphs. This is one of the charts that we use as engineers to tell us what happened in the earthquake. This has been produced by the University of Auckland. Up the side is effectively the amount of shaking, and along the bottom is a measure of a building's period, basically how long it takes to move from one side and back again. The short ones are on the left, moving through to taller buildings on the right. The blue line is a 1 in 500 year earthquake, which we designed to, and the other is the no damage line, the 1 in 25 year line. The ones shown are for Wellington sites on deep soil. Ones for other places around the country are usually less. For example, Auckland's would be about a quarter of this. The government decides for us as engineers, and so society as a whole, what this 1 in 500 year and 1 in 25 year lines are, as a balance between people's safety and cost. All of the squiggles are from different recording stations around the country. You might remember seeing the earthquake readers which make those wavy lines in an earthquake. Some very smart people take that information and turn it into these coloured lines, which then tell us how the shaking was at different places. As you can see, for short buildings and very tall ones, the lines are quite low. Not much shaking happened, but for the middle ones, they're quite high and above the no damage 1 in 25 year earthquake line. Different places around the country and even around the city had different levels of shaking. and the shaking varies in different directions. This line is measured in Miramar, and this one is Wellington Waterfront. And this one over here on the left is Blenheim. So you can see it's really quite complex, and we can't just say below this number on the Richter scale everything is sweet. Every earthquake which happens is different. The lines from Christchurch earthquakes look different again to these. And if we had a closer earthquake to Wellington, the lines would look different again. Percentage MBS, or percentage of new building standard. These two design lines are from our current earthquake code, which started in 2006. When we talk about a building being a percentage MBS, we mean that the bones of the building could withstand that much proportion of this line. Before 2006, usually this line was much lower. This is one of the reasons that buildings need to be strengthened. The dotted line is 33% MBS. Buildings which fall below this line are called earthquake prone. As you can see, it's much more likely that the squiggly earthquake lines will be above this 33% line. The way that we currently design for earthquakes, and that we pick which elements of the buildings are going to fail first, has only been around since the 1960s. And we're constantly learning new things every time there's an earthquake. We will learn things from Christchurch and we'll learn things from these events. Unfortunately, it's not as easy as punching a whole bunch of numbers into your computer and it's spitting out an answer. Why don't engineers tell me my building is safe? We engineers never use the safe word. A building is never risk-free. It's like a car with airbags. It's safer than one without, but it still can get in a crash. There is no such thing as earthquake proof. There's always the possibility of getting a bigger earthquake than what we've designed for. Everybody has a different appetite for risk. We can only tell you if your building is more damaged than what it was 2 weeks ago before the earthquake, and then you have to decide if you're comfortable with that. Safe is a black and white term, but we're dealing in a spectrum. So, should I go live in the middle of an empty field? It's all a bit scary, all this uncertainty and waiting for earthquakes and aftershocks. But it's important to remember that earthquakes are only a small bit of risk in our lives. We don't get scared jumping in the car every day, even though 300 people a year die on the road. Even if you're a good driver, there are many terrible drivers out there. Earthquakes are a bit like terrible drivers. There might be one round the next corner, or you could go for ages without encountering one. Remember that heaps of pictures of undamaged buildings don't make good TV, and a 5-minute video explaining about engineering and earthquakes isn't that clickbaity, so it's no wonder that media coverage can skew a bit on the scary side. Thanks for watching. I hope I've managed to shed some light for you.